All right, this is section 3.4 for business calculus, and we're going to practice more with optimization. Okay, so in this section, we're going to continue to solve optimization problems, and we're going to see how to maximize a company's profit if we're not given a price function, but we're provided with enough given information to describe how price changes will affect sales. And we're going to see that sometimes X should be chosen as something other than the quantity sold. Okay, so looking at example 1, we see that a store can sell 20 bicycles per week at a price of $400 each, and the manager estimates that for each $10 price reduction, she gets to sell 2 more bikes. So the bicycles cost the store $200 each. We want X to stand for the number of $10 price reductions. And for this example, we want to find the price P and the quantity Q as functions of X. All right, so we're going to start with a price function. We're going to find P of X. And it says that the store can sell 20 bicycles per week at a price of $400 each. Okay? And the manager estimates that for each $10 price reduction, she'll sell 2 more bikes. So let me write this out real quick. Our X is equal to the number of price reductions. There we go. So when we write this price function, we're starting at $400, and then we're going to take off some money, okay? So we're going to take off $10 each price reduction. So our price function becomes 400 minus 10x, okay? Your 400 is your original price. That says price. Original price. And 10x is the number of $10 reductions. All right, we also need to find the quantity function. That goes back to the very beginning of the sentence, the very beginning of the example. It says, right now they're selling 20 bicycles per week. But for every $10 price reduction, they're selling 2 more bicycles. So we start at our original starting point, the $20 that we're selling, and we're going to add 2 bikes per reduction. Okay? So that's the first example. P of X equals 400 minus 10x, and Q of X equals 20 plus 2x. All right, we're going to use this information to help us in example 2. So, example 2 says, using the information in example 1, find the price of the bicycles and the quantity that maximize the profit. We also need to find that maximum profit. So recall, I'll squeeze down just a little bit, that your profit function, is your revenue function minus your cost function. So the first thing we need to do is find our revenue and our cost. So recall from example 1 that price function was 400 minus 10x, and the quantity function was 20 plus 2x. So now, using that information, let's start with our revenue function. Recall that revenue is price times quantity. So R equals PQ. So our price is 400 minus 10x, and our quantity is 20 plus 2x. And we can multiply that all together, and we end up with 8,000 plus 600x minus 20x squared. All right, then we need to find our cost function, and recall that your cost is the unit cost times how many you're selling. Okay? if you look back in example 1, it says the bicycles cost $200 each to the store. So that's our unit cost. So our cost function is going to be our unit cost times our quantity. So we have 200 times that quantity that we found, 20 plus 2x. So now we're going to multiply that together, and we end up with 4,000 plus 400x. Once you have revenue and cost, you can then find profit. Again, we want to maximize the profit. Whatever we're trying to maximize, that's our hint that we need to get to that number. Or that, not that number, sorry. We need to get to that equation so that we can maximize it. So my profit function is my revenue. So the 8,000 plus 600x minus 20x squared minus the cost. All right, if we put that together, we end up with a function that is 4,000 plus 200x minus 20x squared. Okay, maximizing profit. Maximizing or minimizing any function, you've got to take the derivative. Okay, so I want you to find that value. Take the derivative, find that critical number, and then come back and check. So pause the video and do that. All right, so if you take the derivative of the profit function, you end up with 200 minus 40x. Solving for x gives us x equal to 5. We can prove that it is a maximum by taking the second derivative of the function. P double prime of x gives us negative 40, which is always negative. So x equal to 5 is a maximum. So now, once we have that, the next part says find the price and the quantity that would maximize the profit and find your maximum profit. Okay, you have all of those equations. I'm going to scoot over here. Our price function, so P of x was 400 minus 10x. So P of 5 gives us 400 minus 10 times 5, giving us a price of $3.50. Okay, so we need to sell them for $3.50. The quantity function was our 20 plus 2x. So Q of 5 gives us 20 plus 2 times 5, giving us 30. So we're going to sell 30 bikes at $350 each. And our maximized profit, so that profit function, which was our 4,000 plus 200x minus 20x squared, putting 5 into that profit function, gives us $4,500 a week. All right. So if you look at, we'll go down here. So finally we see the answer, we state the answer clearly. If we sell the bicycles for $350 each, we can sell 30 per week, giving us a maximum profit of $4,500. Hello? Say it one more time. Oh, hold on, I can go ask Justin. Let me make sure my thing. Okay, so in example 2, we did not choose X by the quantity sold, but instead to be the number of $10 price reductions. We chose this X because from it we could easily calculate both the new price and the new quantity. Other choices for X are also possible, but in situations where price change will make one quantity rise and another fall, so in this case, the amount we sold rose while the price fell, okay, it's often easiest to choose X to be the number of such changes, okay? And we're going to see that as we go through the rest of this lesson, okay? I'm going to do the next couple of examples on the next video.